Hello, my name is Phan. I am a Doctorate of Business Administration student at California Intercontinental University. This presentation fulfills a requirement for Unit 4 of GRC 605, Term 1, 2019. In this presentation, I'm going to be presenting statistical findings from a statistics software known as PSPP. During this presentation, we are going to review the data that has been provided to the students taking this course. The data comes from an Excel file that we will discuss on the next slide regarding its contents. However, using that data, we utilize bivariate correlation functions with PSPP to discover which variables within the data have statistical significance. The main content of this presentation will be looking at 6 of these significance tests and determine what the outcomes of the test tells us. We will then wrap this presentation up by reviewing key takeaways and leave additional time for questions and answers. Starting with this presentation, we will be looking at the same set of data provided by California Intercontinental University. The GRC 605 dataset is comprised of a distilled version of an actual SurveyMonkey survey delivered to a population located in the United States, Midwest. Their survey is asking questions about their personal finance situation. There are 10 variables total which make up this data: income, debt, saving, stocks, and here begins the variables which require further clarification. Wallet, this is the self-reported amount of cash the individual carries in their wallet or purse. Dumb cars equals the number of car payments per month by the participant. Num-C cards equals the number of credit cards maintained by the participant. Number of defaults, the number of defaults of all types incurred by the participant. Like comfort, so this equals the self-reported comfort level or the participant with the current financial standing. The measure used a Likert scale where 0 equals very uncomfortable to 4 very comfortable. The screenshot of the data is an example of how the data variables are organized. As part of the exercise for this unit, we are asked to take the data set and insert it into PSPP to calculate the following correlations: income and debt, income and savings, income and stocks, income and wallet, debt and savings, debt and stocks, debt and wallet, savings and stocks, savings and wallet, stocks and wallet. 6 of these correlations, after being calculated, contain significant correlations. As shown on the list on the right side of the screen, note the numbers as in future slides I will be referencing the hypothesis test that corresponds with the number. The variables will be mentioned as well for additional information. We will now look at each significance test. The first hypothesis test was to find a correlation between personal income and savings. The null hypothesis, therefore, would seek to state that there is no correlation between income and savings. The alternative hypothesis states that there is a correlation between income and savings. In each of these hypothesis tests and throughout this course, when discussing the data set, we will always assume that the alpha is 0.05. Our data states that R is 0.91, a strong positive correlation, and our p-value is 0.00. In this case, because p-value is 0.00, this indicates we have a strong evidence from the sample that the null hypothesis can be rejected. Therefore, we will say that there is a correlation between income and savings. The second hypothesis test was to find a correlation between personal income and stocks. The null hypothesis, therefore, would seek to state that there is no correlation between income and stocks, and the alternative hypothesis states that there is a correlation between income and stocks. In this comparison, our data states that R is 0.19, not a very strong positive correlation, and our p-value is 0.18. In this case, because p-value is 0.18, this indicates we have a weak evidence from the sample, and that the null hypothesis can be rejected. Therefore, we will stick with the null hypothesis and say that there is not a correlation between income and stocks. The third hypothesis test was to find a correlation between personal income and wallet. Again, wallet means this is the amount of currency someone has had in their wallet or purse. The null hypothesis, therefore, would seek to state that there is no correlation between income and wallet. The alternate hypothesis states that there is a correlation between income and wallet. Our data states that R is 1.00, a very strong positive correlation, and our p-value is 0.00. In this case, because the p-value is 0.00, this indicates we have strong evidence from the sample that the null hypothesis can be rejected. Therefore, we will say that there is a correlation between income and wallet. The fourth hypothesis test was to find a correlation between savings and stocks. The null hypothesis, therefore, would seek to state that there is no correlation between savings and stocks. The alternate hypothesis states there is a correlation between savings and stock. Our data states that R is 0.28. In this case, not a very strong positive correlation, but our p-value is 0.00. In this case, because p-value is 0.00, this indicates we have a strong evidence from the sample that the null hypothesis can be rejected. Therefore, we will say that there is a correlation between savings and stock. The fifth hypothesis test was to find a correlation between savings and wallet. The null hypothesis, therefore, would seek to state that there is no correlation between savings and wallet. The alternate hypothesis states there is a correlation between savings and wallet. Our data states that R is 0.91, a strong positive correlation, and our p-value is 0.00. Again, in this case, because p-value is 0.00, this indicates we have strong evidence from the sample that the null hypothesis can be rejected. Therefore, we will say that there is a correlation between savings and wallet. The sixth hypothesis test, and the final hypothesis test we'll be reviewing, was to find a correlation between stocks and wallet. The null hypothesis, therefore, would seek to state that there is no correlation between stocks and wallet. The alternate hypothesis states that there is a correlation between stocks and wallet. Our data states that there R is 0.19, a weak positive correlation, and our p-value is 0.017. In this case, because p-value is 0.017 and still less than 0.05, this indicates we still have strong evidence from the sample that the null hypothesis can be rejected. Therefore, we will say that there is a correlation between stocks and wallet. I thought it would be good to show the scatter plots of each of these hypothesis tests to summarize these tests visually. Going from left to right, number 1 is income and savings, 2 is income and stocks, 3 income and wallet, 4 savings and stocks, 5 savings and wallet, and 6 is stocks and wallet. Hypothesis test number 2, income and stocks, was the only hypothesis test that we stated that the null hypothesis was not rejected, meaning that there is no correlation between income and stocks. I found the hypothesis tests number 4 and number 6 had interesting results. Although both tests did not appear to have strong correlations, R values, their p-values still were able to determine that there was enough evidence to say that we can reject the null hypothesis. Here are 3 takeaways from this presentation. PSPP is an easy-to-use statistics software that will calculate the Pearson's R and p-value for hypothesis testing. Understanding the significance of the R and p-value are vital for analysis of statistics testing. The p-value determines if you can reject a null hypothesis or fail to reject. If the p-value is less than 0.05, you have strong evidence to reject the null hypothesis. It is important to list your p-value for this purpose as evidence of the strength of your sample. Thank you for viewing this presentation. In this exercise, we are tasked with utilizing PSPP to identify statistical significance between various variables which could or could not be correlated. Hopefully, this presentation gave you a better idea of the effectiveness of using statistical software for calculating your statistics data. I will now leave any time for any questions.